Number 6 is a proportion. A proportion is a fraction equal to another fraction. And please remember that if you have a fraction which is equal to another fraction, isn't it true that 2/4 is equal to 1/2? Their cross products, 2 times 2, will be equal to the other cross product, 4 times 1. 2 times 2 is 4, 4 times 1 is 4. So I could take this and multiply those together and set that equal to that product because I have a fraction equal to a fraction. So that will be, and I'm going to put it way down here, that will be, and I'm going to erase this. So the upper left and the lower right will be 4 times x minus 7, and the upper right and the lower left would be 1 times x plus 2. And you have gotten rid of your denominators and you can solve this equation. However, I'd like to remind you that the LCD for this problem is 4 and the x plus 2 because none of these can be factored. The x plus 2 is a binomial, I can't factor it, so I have to include both of those. So if I were to multiply this first fraction here by the 4 times the x plus 2, and also the right side by the 4 times the x plus 2, so both sides get multiplied by the LCD, then notice that this denominator and one of the factors I multiplied by would be removed. And notice that this 4 and that 4 would be removed because it's 4 over 4 is 1. So you're left with 4 times x minus 7 and 1 times x plus 2. So actually I'm going to go ahead and put it here. It'll give me more space to do this. The 1 times x plus 2 is really not necessary. The right-hand side will just be x plus 2. And on the left side, I'll distribute the 4. And now I'll go ahead and solve this linear equation. You remember, I like to work with the x's first, so I'm going to subtract x from both sides. So I'll have a 3x minus this 28 equals 2. Yes, I do shortcuts sometimes, but I'm trying not to illustrate that in front of you. Like I might have added 28 to both sides at the same time. Some people can do this in their head right here. They can add 28 to both sides without writing the step down. So 2 and the 28, they know that's going to be a 30. And then right here, some people won't show the dividing both sides by 3 to find the solution of x is equal to 10. But again, you know, if you want to transpose, if you don't want to show the work, that's fine. I'm going to go back here and erase this. I'm going to go ahead and try to do a better job of checking this answer. So x is 10. So everywhere I see 10. So I'm going to put a 10 minus 7 in the first numerator and a 10 plus 2 in the denominator. And I'm going to compare that and see if this fraction, 3 over 12, is equivalent to 1/4. And it sure is, so I'm good to go. So again, if you would maybe hit pause and go ahead and solve this next problem, but because it's one fraction equal to another fraction, I know, and also these are the common denominators, 2x minus 3 and 3x minus 1. So if I multiplied this fraction by both of these, the 2x minus 3's would cancel out and the 5 would get multiplied by the 3x minus 1. And then this fraction, if I multiplied it by both binomials, the 3x minus 1's would cancel out and the 7 would get multiplied by the 2x minus 3. Please go ahead and do the distributing work, the 15x minus 5 and the 14x minus 21. And would you solve this problem for x? And I get x equals a negative 16. Soon I want to start talking about the fact that there are some answers for x that will not work. And I think I'll do it when we get to question number 9. But let's go ahead and go over here and get back to this one. So the reason I want to do this one still, even though the LCD is equal to 6 between the 3 and the 2, I'm going to go ahead and show you that I'm going to multiply this by 6, this fraction by 6, and this 1 by 6. And I want you to see here, because we haven't really had to do this quite yet, that 3 will always divide into the common denominator. In this case, 3 divides into 6 twice. And what you have here is 2 times the x plus 1. So 2 times the x plus 1. And right here, 2 will go into here once and into here 3 times, and you'll have 3 times this x minus 1. Be careful, there's a minus sign. You'll have a minus 3 times that x minus 1. And on the right side, you'll have 1 times 6. So let's go ahead and distribute. So we have 2x plus 2. And as long as we caught this minus sign, when we take this minus 3 times this minus 1, we'll get a positive 3. And then be careful to combine your like terms on the left. They are on the left side of the equal sign. Just add them together. 2 plus 3 is 5. Don't be adding things to both sides. But now we're ready to subtract the 5 from both sides. And we have a negative x equals a positive 1. And that negative x is a negative 1x. So we'll divide both sides by a negative 1. And x is equal to a negative 1. And we would go in and check that. And I am confirmed that that is correct. Okay, I want to talk now in this problem, before we go any further, about the fact that this denominator and this denominator have some letters for t that will not work. For example, if you found t was equal to 2 and you went to check this problem, a 2 there for t, and then subtract 2 would cause a 0. And you can't divide by 0. So I'm going to list the restrictions now here on the domain of this function. And one of the values for t that cannot occur is a 2. Here, if t turned out to be a negative 4, we'd have a problem also, because a negative 4 plus 4 is 0, and you can't divide by 0. So t cannot equal a negative 4 as well. So I'm going to start checking that as I go along. But now let's go ahead, because this is just a proportion. It's a fraction equal to another fraction. Let's take this product and set it equal to that product. So t plus 5 times t plus 4. And then let's do this binomial times this binomial. So t minus 2 times t minus 2. And you may be going, this is looking pretty involved here, because there's going to be t squared terms. And there is. When you FOIL this, which is what you've got to do, t times t is t squared. And then here I get a 4t and a 5t, which is a total of 9t. And 5 times 4 is 20. On the right side, again, t times t is t squared. And if you don't mind, this minus 2t and that minus 2t is a minus 4t. And a minus 2 times a minus 2 is a positive 4. So what do I do with these t squareds? I subtract them from both sides, and they disappear. It's not to say that we won't sometimes have a t squared term, but this one turns out to be relatively simple. Be careful of that 4t. It's got a minus sign in front. And now let's solve this thing for t. Pat prefers to work with the smaller coefficients in front of the variables. So since that's a minus 4t, I prefer to add 4t. That promises that I have a coefficient in front of t that's positive, 13t. And I just like positive numbers. Next, I'll subtract 20 from both sides. So subtract 20, and I have 13t on the left equals a negative 16. And finally, I'll divide both sides by 13. And I find out for this problem, t is equal to a negative 16 over 13. That's my answer. It did not turn out to be 2 or a negative 4. Yes, I should put it in here and solve and check these. Be careful, if you use your calculator, you should put it in parentheses to do that. So when you go to put that into your calculator, I'll just go ahead and demonstrate the left side. So if I was typing in this left side, I would go in parentheses a negative 16 divided by, I think it was 13. Yep. Plus 5, and then I close the parentheses, divide by, then open parentheses, and this t minus 2 right here would be a negative 16 divided by 13 minus 2, close the parentheses. Let's hit enter. Let's go ahead and figure it out. The right side of the equal sign says take your t value, which is a negative 16 divided by 13, and subtract 2, close my parentheses, then divide by, open my parentheses, a negative 16 divided by 13, and that one's a plus 4, close my parentheses. I hope it's a negative 1.1667. So the left side did equal the right side when I put my solution in, and therefore it checked. I I'm trying to decide if we should go ahead and capture this one. I'm going to look ahead a little bit. Yeah, let's go ahead. Let's go ahead and do this one. So you got to find the least common denominator. And to do that, you've got to factor the denominators. So 2 comes out of each of these. And when you do, you get a 2x minus 3. The number 4 is 2 times 2. And then finally, this 2x minus 3 can't be factored. So my LCD for this problem, and it might be easier for you to keep the 2 times 2 and then the 2x minus 3. And that's what you're going to multiply all the fractions in this problem. I'm going to go ahead and rewrite this. You have 3 over 2 times 2x minus 3. And then you have 1 over 4, which is 2 times 2. And then you have 5 over 2x minus 3. Could you start to notice now that if I multiplied this fraction by the whole LCD, 2 times 2 times 2x minus 3, that one of the 2's and the 2x minus 3 will cancel. One of the 2's and the 2x minus 3 will cancel. So if I notice this had the 2 and the 2x minus 3, from now on, I might come on over here and say the only thing missing in this is the number 2. In the LCD, there's 2 2's and a 2x minus 3. This one's got a 2 and a 2x minus 3, so the 3 has to be multiplied by a 2 to get the first term and clear that. See this 1/4? The 2's will both cancel out. So the 1 is going to end up getting multiplied by just the 2x minus 3. I'm trying to show a little shortcut because when you multiply this by 2 times 2 times 2x minus 3, the 2's, the sets of 2's will cancel out and you'll be left with 1 times 2x minus 3, which is just 2x minus 3. See the right side? The 5 over the 2x minus 3? It's got this, but it doesn't have the 2 2's or a 4. So I might just come over here and just say I'm going to multiply the right side 5 times 4 and just get a 20. And so I knew that this, if I multiplied this by 2 times 2 times 2x minus 3, that the 2x minus 3's would cancel out and the 5 would get multiplied by 4. So from now on, we might try to shortcut this. Here on the left side, we've got 6 minus 3 is 3. We'll subtract 3 from both sides. I'm not going to show that step. That'll give me 17. We'll divide both sides by 2, and we'll get 17 over 2. We'll come back to some harder problems in our next segment.